Good evening to all of you. Uh, I am now starting a new chapter, that is drainage requirements for irrigated lands, which is very essential, like the water conservation and water application. They are important. At the same time, the drainage requirements also are very important. If we are not providing a proper drainage, you will not be finding a good yield for the program, for the crop. Okay, so let us go to the presentation now. Uh, you can see the need of the drainage for plant growth. This is very important. How we are discussing, plants need air as well as moisture in their root zones for their survival. It's not that you need only water. You need some aeration for the root zone. So if you are submerging the entire subsoil under submerged conditions, it will not plant will not survive. Of course, you can say the rice is how rice is surviving, sir. No, it aerate through its tubes, though it is completely filled with, all the voids are filled with water. So for every plant there is a need of aeration in the root zones. So therefore excess water, excess farm water, if any, if you are simply putting only that much of water like your sprinkler and drip, doesn't matter. But if you are putting excess water like gravity, surface irrigation, any excess water has to be removed through the drains. This is very important. Okay, we have to remove those water, excess water, after fulfilling the soil moisture deficiency. The excess water should be removed properly. Otherwise, what will happen? This water retards the plant growth because it fills the soil voids and restrict proper aeration. This is what we have been saying. So it will fill the soil voids and restrict the aeration. So proper oxygen for circulation is very much needed for this root zone. Okay, surface drains are therefore needed for removing the excess farm water for most of the cultivated crops on flat or undulating topography. So, if as per the requirement, you should provide the surface drains. Actually, there are two drainage systems here. One is the surface drains, another one is the subsurface drains. They are also called tile drains. So, surface drains, if they are useful, you can provide. Otherwise, you can go for this subsurface drains. On the other hand, are required for soils with poor internal drainage and with high water table. So where there is a water table is high, but there is a poor internal drainage, like it is a highly clayey soil. Okay, so then you have to go for definitely subsurface drains or tile drains. Yeah, subsurface drains also called tile drains. If no impervious layer occurs below the farmland and the water table is very low, internal drainage may be sufficient and no tile drains are needed. Suppose if the water table is deep and there is no impervious like clay layer below the root zone system, then there is no need of any tile drains. Simple internal drain system, internal drainage is good enough. The maximum productivity of most of the crops, both surface as well as subsurface drain, are therefore essential. So, if you want to extract maximum output or good crop from yield, if you want to expect good yield from the crop, you need to have these surface or subsurface drains. You can see here how the effect of drainage on plant growth. Here, one is undrained land. This one is a drained land. See, within undrained land, you can have a during this spring and during this summer. Means you can say here our Rabi season and summer. You can see if the water level is too much, even up to the root zone, the growth is growth impediment you can observe. Here, the little bit down during summer, the water level much more growth, but not much leafy. Whereas you have provided the drained land. Here is a drained land. You have given good drainage both in spring as well as summer. With compared to the spring, the summer, because water level is down and much aerated, you can see the root, how the root development here compared to here root development is much denser, and then canopy development is much denser, and also similarly the yield is higher. So this is how the drainage, it's not that water alone, if you provide and then other things you neglect. You have to carefully plan your drainage requirements also. That is very important for any irrigated lands. So in this chapter we will discuss some of those drainage requirements, layouts and other things. Okay, so then let us go for one by one. This is a I think this figure has come very late anyway. These are all some of the things. Okay, this is a behave, surface inlet, behave grade, and you can see pit water. See, some of this water is simply taken down here, subsurface drain here, and this is called surface inlet draining. Surface inlet draining the surface water into a tile drain. Both from the surface, we are directly connected to an inlet, and then there is a subsurface drain which is called tile drain also. So around this pipe you can put a concrete collar, and of course sealed joints are there. Okay, these are the arrangements, self-explanatory. There is a kind of water stagnated here. No, this is a French drain. It is called. What is happening? It is a low lying, and then water is stagnated here. You will have a blind inlet. It is called blind inlet. This is a trench excavated after the for this dimension. You can see. Then there is a pipe or tile drain provided. This excavated trench is filled with corn cobs, cinder or other porous material here. Excavated slope of trench. This is filled with some porous material, below which there is a pipe. Pipe also porous. So like this, you can see this water table is always maintained up to here, not allowing up to the root zone. See, water table is here only. Okay, so this is the surface ground level. Okay, this is another arrangement. Then cross section of a tile drain in pervious soils. Okay, if there are soils are pervious, simply you provide this pipe drain, backfilling with sand and excavated material itself. You need not put any other material. You simply put the same material here, but there is a pipeline. Not necessarily always you have a depression here. It is a general one. You can put a pipeline here. Okay, and then automatically it gets drained. The water gets drained. So that is how the water table is kept low. You can see here. It is not allowing up to top. It will be within this pipe. Then pipe level. Here, if the only difference between the earlier one, this one is backfilling with excavated earth. Some graded filter is arranged around this. Therefore, uh, backfilling of excavated depth to some extent, but their graded filter is arranged. That is the inverted filter. Okay, you can say. Here also, similar effect you can observe. The water table is maintained at a certain depth below the root zone, not up to the root zone it is touching. Okay, so this is a cross section of a tile drain with a less pervious soils. Earlier we have seen pervious soils. This is a gravity outlet for tile drains. You can see there is a outlet drain. Normally, it is a metal pipe, minimum length 4.5 meters and a diameter 5 centimeters more than that of the tile. You can see this is a concrete collar. Now, what is happening is you are having a pervious pipe, and the water is simply percolated to this, and then this entire water is by gravity flowing, and this is an outlet drain. It will be dropping. It will be dropping here. So flood or flap gate here, and this is an outlet drain. So this entire earth water, which is excess found, it will be drained out like this. Okay, next. Here is another pump outlet for tile drains. Pump outlet for tile drains. You can see here water is pumped instead of gravity. The water is this is a of course tile drain arranged and then accumulated over a stop well. This is a starting level, of course. Sump storage. You are storing into a well, and then this is particularly in waterlogged areas. Mostly it is observed, and the water is pumped and then put into an outlet ditch here. Then this will go by surface drain. Pump outlet for a tile drain. You can see this is a pervious tile drain, and then water is coming in, and then it will be stored here, and it is then pumped to the up and then to a drain. So these are the various mechanisms. Then we will see. We will come back again with the video again and to the tile drain layout. I will stop here. Thank you very much.